The Sun is entering a heightened phase of its 11-year activity cycle, and 2025 could feature some of the most intense solar events in the current solar cycle, 25. NASA and NOAA have already flagged these developments, warning that heightened space weather activity may affect everything from satellite navigation to power grids. With headlines describing impending solar explosions, the question is how these bursts of solar energy might impact daily life across the United States. After all, 2024 brought multiple geomagnetic storms that disrupted radio signals, shook power grids, and lit up the skies with low-latitude auroras. The year ahead appears poised to continue that trend or possibly intensify it. Solar cycles follow an 11-year pattern. Each cycle begins quietly at solar minimum, intensifies toward solar maximum, then descends again. As of late 2024, scientists confirmed the Sun's recent surge has already exceeded the peak of the previous cycle, Solar Cycle 24. That puts Solar Cycle 25 in robust territory, with many more sunspots than anticipated. These sunspots often spawn solar flares and coronal mass ejections, hurling magnetized plasma toward Earth. When that plasma collides with Earth's magnetosphere, it can spark geomagnetic storms, ranging from G1 minor to G5 extreme. Though no one can pinpoint the exact month when Solar Cycle 25 will crest, NASA and NOAA note that we're already near maximum or sitting right in its midst. This elevated phase can last a few years, so 2025 offers ample opportunity for major solar explosions to strike Earth. In 2024, storms in May and October highlighted how consecutive coronal mass ejections can arrive back-to-back, amplifying their impact on power grids and communications. That pattern may continue, since formidable flares don't always match the official numerical peak of the cycle. When people say solar explosion, they generally mean two phenomena. First, solar flares, eruptions of electromagnetic radiation such as X-rays, ultraviolet light, and radio waves that reach Earth in about 8 minutes. Powerful flares can ionize our upper atmosphere, momentarily disrupting radio signals used by aircraft or mariners. Second, coronal mass ejections, bubbles of hot, magnetized plasma ejected by the Sun, often traveling for a day or more before hitting Earth. If the trajectory is Earth-directed, the collision of that plasma with our magnetosphere triggers geomagnetic storms. These storms can be mild or intense, but in a year of strong solar activity, the risk of major disruption climbs. In early 2024, one particularly large sequence of CMEs produced the most severe geomagnetic storm in 2 decades. Auroras dazzled skywatchers far from polar regions, and precision agriculture took a hit when GPS signals failed, costing the U.S. farming industry hundreds of millions of dollars. Another storm in October led NASA and NOAA to warn that we are solidly within a phase of high solar activity. As 2025 approaches, the same conditions that birthed those events remain present, making comparable storms likely in the months ahead. There is also the question of whether the biggest flares might occur after 2025, since previous cycles sometimes saw their strongest eruptions 1 or 2 years after the peak sunspot count. Yet that doesn't diminish this year's hazard. It merely extends the window during which large storms can appear. A prime concern is the power grid. Geomagnetic storms can induce surges in electrical transmission lines, placing transformers under stress. Utilities can take precautionary measures if they know a major coronal mass ejection is en route. But that warning period depends on satellite data and the CME's speed. In older episodes, like the 1989 storm that blacked out Quebec, entire regions lost power. Although modern grids have better safeguards, an extreme event could still create localized blackouts and economic turmoil. In 2024, no large-scale outage happened, but the $500 million loss in automated farming showed that the electric and communications infrastructures are more fragile than many assume. Satellites in low Earth orbit also face heightened risk. Geomagnetic storms heat Earth's atmosphere, causing it to expand slightly and increase drag on satellites, which could lose altitude unless operators make orbital corrections. Electronics can be zapped by charged particles, causing glitches or permanent damage. GPS signals can be thrown off by a few meters or more, problematic for applications like aviation, shipping, and even ride-hailing services. The bigger the solar flare, the more dramatic the radio interference. In 2023, a strong flare caused brief but noticeable blackouts on certain aircraft communication routes. Extrapolate that to 2025, when flares may be stronger, and you see how routine flights could face detours. Auroras, on the other hand, are the more appealing byproduct of these storms. In 2024, many Americans in states like Missouri, Virginia, and even parts of California reported seeing the northern lights dancing overhead. Such occurrences typically require a geomagnetic storm of at least G3 intensity. Given that we are still near the cycle's maximum phase, the odds of repeated G3+ storms remain high. For many, it's a once-in-a-lifetime spectacle. If 2025 brings more G4 or G5 storms, auroras could again radiate across large swaths of the country, triggering social media buzz and pushing more people to follow space weather alerts. The flip side is that each mesmerizing aurora display often hints at possible radio or grid disruptions lurking in the background. One sector feeling acute strain is agriculture. Modern farms rely heavily on GPS-driven equipment to minimize labor and maximize yields. If a storm knocks out precise signals during planting or harvesting, entire fields can be missed or overlapped. The 2024 episode that cost hundreds of millions underscores this vulnerability. In 2025, farmers might face repeated short windows of interference. While forecasts can help, agricultural timelines are unforgiving. You can't always delay planting if conditions on the ground are otherwise ideal. A miscalculation at the season's start can cut yields and profits. Aerospace research and crewed missions also keep a watchful eye on solar flux. The International Space Station, orbiting relatively close to Earth, experiences a heightened risk of radiation exposure during big solar flares. Astronauts can move to more shielded compartments, but repeated incidents reduce operational flexibility. Robotic missions, from Earth observation satellites to experimental spacecraft around the Moon, may need to shut down critical instruments briefly or risk radiation damage. With NASA aiming for more robust lunar activity and private companies launching dozens of satellites monthly, 2025's strong solar environment might test protocols in place to safeguard hardware and crews. Another angle is polar airline routes. During strong solar flares, the polar regions can experience radio blackouts and higher radiation. Airlines sometimes reroute flights over less direct routes, raising fuel costs and extending flight times. In December 2023, an X5 flare forced brief communication adjustments. A bigger X9 or X10 flare might cause more drastic detours. Though these events are short-lived, they can affect flight schedules if storms arrive during peak travel. Passengers could see unexpected disruptions, and cargo shipments might be delayed, leading to ripple effects in global logistics. Just as with any natural phenomenon, public sentiment can swing between fear and fascination. Major storms bring talk of telegraph lines catching fire in the 1859 Carrington event or the 1989 Quebec blackout. Yet they can also foster excitement over auroras. In 2025, that tension remains. Space weather watchers love the spectacle, but industries hold their breath when NOAA issues a G4 or G5 warning. If back-to-back events occur, the disruptions could compound, particularly for businesses that depend on electricity and reliable satellites. The possibility that a mammoth flare might appear months after official peak sunspot counts only extends the zone of concern well beyond 2025. In addition, partial solar eclipses in March and September 2025 may nudge people toward greater solar awareness. While these eclipses aren't the total show that crossed the U.S. in 2024, they might still offer glimpses of solar features like prominences when viewed with proper filters. Although an eclipse itself doesn't heighten flare risk, such events spark curiosity and discussions about sunspots, space weather, and flares. Interest in the sun's volatility could jump if an eclipse coincides with an active region of sunspots. This broader context of increased solar engagement includes the possibility of more NASA missions monitoring the sun. Spacecraft like the Solar Dynamics Observatory and Solar Orbiter produce near real-time images of sunspots, flares, and CMEs. If 2025 is rife with these explosions, scientists will collect treasure troves of data to refine their understanding of how solar cycles evolve. That in turn might improve the reliability of future forecasts, something industries badly want. At present, large storms can be predicted just a few days in advance, but more detailed models might eventually offer extended lead times. Still, the potential for an extreme G5 superstorm looms. While not likely in any given year, the prolonged solar maximum means at least one or two intense events may happen before the cycle declines. A direct G5 hit could lead to localized blackouts, fried satellites, and large-scale chaos in radio communications. Utilities have been adding resilience protocols, yet total immunity is not assured. Even short outages in major cities can spark logistical nightmares. On top of that, repeated storms in quick succession could strain resources. Satellite operators might manage single events, but multiple hits could deplete backup fuel or push hardware beyond safe tolerances. For everyday Americans, 2025 might mean occasionally seeing odd weather alerts, not about hurricanes or blizzards, but about geomagnetic storms. They might experience fleeting cell or TV signal disruptions or spot unexpected displays of the northern lights. Farmers might share local scheduling tips around predicted flares, and airline passengers might see slight route changes. People living near latitudes where auroras rarely appear could spend nights outdoors hoping to witness the swirling lights for the first time. Social media platforms might light up with photos of pastel skies in states more familiar with scorching summers than shimmering auroras. Beyond illusions of random space weather, these storms also reinforce how dependent modern life is on satellites and electrical grids. Even mild disruptions reveal that intangible cosmic forces can ripple through supply chains, travel, and personal electronics. While some might brush off the notion of the sun affecting Earth, 2024's $500 million farming blow was a reality check. For 2025, that effect might be repeated if we see more episodes of strong flaring. The unpredictability can frustrate those needing clear timelines. A CME is only identified as Earth-targeted once satellites see it. If it's traveling fast, we may have less than a day to get ready. On the policy side, NOAA's Space Weather Prediction Center remains the nation's go-to resource, issuing alerts for flares and CMEs. The center's Aurora forecast has become widely consulted, helping enthusiasts plan road trips to darker skies for potential sightings. Stakeholders in energy, aviation, and telecom check NOAA bulletins for storm strength and arrival windows. Some local governments even incorporate space weather contingencies into emergency planning, though these measures vary widely by region. The hope is that a single powerful event in 2025 doesn't catch anyone off guard, but readiness is uneven. In the longer view, even if 2025 sees no cataclysmic storms, we're still gleaning lessons for future cycles. Solar Cycle 25 may remain energetic into 2026 or 2027, and subsequent cycles will likely bring their own extremes. Each flare and CME that hits Earth offers data to refine models and protect vulnerable systems better. The ultimate goal, is to treat solar weather much like terrestrial weather, understandable, forecastable, and manageable. But we're not there yet. The sun's complexity means short-notice warnings remain the norm. Whether 2025 becomes famous for epic auroras or for punishing blackouts will depend on how large and frequent the flares are and how well industries adapt. If the year unfolds with repeated G3 or G4 storms, the spectacle could be breathtaking, matched by nervous moments for utilities and satellite operators. If a G5 storm hits, we could see bigger headlines about grid damage or major flight rerouting. Many will simply enjoy the cosmic show and carry on, never losing power or noticing a GPS glitch. Others might be on the unlucky end of a local outage or the prospect of a solar explosion in 2025 reflects our deeper ties to the changing sun. Earth orbits a star that follows its own magnetic rhythms, and when those rhythms peak, the entire planet can feel the aftershocks. Despite the drama that word explosion implies, the result is a blend of awe and precaution. On the awe side, countless Americans may gaze at brilliant auroras overhead. On the precaution side, industries will scramble to protect satellites, power transformers, and radio links. The real outcome probably includes both extremes. That tension between mesmerizing light shows and real economic stakes defines how the nation navigates solar cycle 25's peak. If nothing else, 2025 will remind us how interconnected we are with a star that sits nearly 93 million miles away, ready to fling magnetic energy into our well-wired world at a moment's notice.